Well, once again, a very good afternoon and a warm welcome to one and all. Welcome back to Global Fintech Fest. Proceeding in today's day, well, we have a masterclass for which we've gathered here, and we have Mr. Ashutosh Meher, Senior Developer Evangelist R3, alongside Ms. Sneha.
Yeah, so I think we are all set. So good afternoon, everyone. My name is Ashutosh, as you already know. I'm a senior developer evangelist at R3, and we generally take care of helping developers get more familiar with Coda and also make sure that they have a smooth journey while they have their Code apps or the applications built on top of Coda and take them to production eventually. So yeah, today's session we are going to focus on making sure that we understand what Coda is, and towards the later half, we will be basically going through some coding. So today, while we say we become a Coda developer in 2 hours, that's what we intend to do. We basically want you guys to understand Coda and then also learn how to build an application. So towards the second half of today's session, we'll take care of real hands-on and we'll build a working application in front of you. We'll get it deployed and make sure that you know how to run it as well. Yeah, so without further delay, we'll get started. So yeah, before we do that, we are also offering free certifications. That's I think over here, we'll just get it sorted. You can take one of the cards here. So that will have a QR code you can scan and you'll get the certifications. You can take the certifications for free, which is generally worth $150. Yeah. And before we start, I would also like to announce that we are now hiring across India. So if you basically want to work in the blockchain ecosystem and you have any interest in that, you can join one of our teams. So we are actually hiring across teams, engineering, DevOps, and a lot of other, a lot of different positions open, specifically in India and Mumbai location. So feel free to go to our portal and apply for the openings. All right, so with that aside, we'll start with a little bit of high-level introduction to what Coda is so that we can set up the background for today. Before we do that, we'll try to learn why exactly Coda was built. Now, as you know, Coda is a completely different platform from what the public blockchains are, right? So it's a permissioned blockchain rather than a public blockchain. But why did we go in that path? Why did we even try to develop something which was not there in the market, right? We could have used something to solve the problem which were there, so something like an Ethereum, or build on top of that something like a Bitcoin. But why did we try to build something completely different, and what was the problem that we were trying to solve? Now, in order to understand that, there are a few things that we need to understand that traditional blockchains have, which doesn't make them very suitable for business-oriented solutions, right? So I'll just cover a few of them. There are quite more, but these are sort of the most prominent ones, I would say. The first problem that you generally see with public blockchains is generally the problem of identity, right? You have a public key. All that you know about a counterparty is a key that belongs to him, right? You don't really know who that party is actually. You don't really know his name, his legal identity, or anything of that sort. So how do you trust someone whom you don't know who it is? So you think of this in a business scenario, right? How do you do business with someone you don't know, right? So that's where the problem of identity comes in. Now, the next problem is around finality. Now, since you guys are here and you're interested in blockchain, I assume most of you might have done some transactions in the blockchain space, right? Maybe a Bitcoin transaction or something. Now, have you noticed, just a second, have you noticed how much time does it take to do a transaction on the Bitcoin, particularly? Let's say there are different times for different platforms, but let's concentrate on Bitcoin. So generally, it takes an hour. That's the general sort of assumption, right? Why does it take an hour? Because there are one block created every 10 minutes at average, and you need 6 blocks for a confirmation. So 6 blocks, 10 minutes, that's 1 hour, right? But do you get your transaction confirmed in 1 hour? Sometimes it takes days, right? Sometimes it takes few hours, sometimes it takes days, sometimes it even gets confirmed before an hour. Now, this complete thing works on the phenomenon of how quickly a block is getting created. Now, that completely depends on basically the network speed and basically your network difficulty and stuff, which I'll not go into. But the idea that I'm trying to convey is, for basically creating a block, there is a possibility that when the 6 blocks are getting created, one of those blocks is having your transaction, and it's probable that the block that is having your transaction is for some reason forged in some nature, right? So what would happen is basically that block containing your transaction will basically be rejected, and your transaction will go out into the unconfirmed pool. It will be mined again, and the transaction would become a part of a block subsequently in the future and get appended to the main chain. But here again, right, it doesn't guarantee that this time around your transaction would end up in a proper block, right? So it's probabilistic in nature. You don't know when your transaction is getting completed, which is not something businesses would want. They want a proper defined timeline, may it be an hour, may it be a day, but you need to know, right, that, well, after a day, my transaction is going to be completed. You don't say, well, probably after a day, maybe it might take 3 days, maybe it would take 6 months. You don't know that. So that's another problem which we are trying to solve, the problem of finality. The next thing is privacy, very important for businesses. As you know, blockchains, public blockchains for that matter, are transparent in nature, right? So anything you put in the blockchain becomes available to everyone. That's one of the perks you have in the public blockchain, but it's not always a perk when you think of this scenario in a business-oriented world, right? You have confidential information, say patented information or some sensitive pricing information. You want to put that on a blockchain and available for everyone, right? That's something not desirable. So there are a lot of different private information that you want to have, and you want only certain parties to know about that, even though you want to be in a blockchain, but you don't want your data to be public in nature. So that's another problem we try to solve. And finally, it's more related to developers, how easy a platform is to use. If you think of any public blockchain, one, obviously for a developer to get started working on it, he'll have to understand blockchain concepts, obviously. And then he'll have to learn a particular platform or platform's language, a particular protocol or a particular programming language. Like, for example, Ethereum has Solidity. Some other languages have some other platforms have some other languages, right? Which makes the learning curve a little steep. Why do you use something like a Solidity or some other new programming language, a new protocol, when there are tons of languages already available? Why not develop something that takes use of these well-proven technologies, and it also becomes easier for developers to adopt that technology and build on top of that using a language which is well known to them, right? So we wanted to make using blockchain or developing on blockchain easier. Right, so what I'll do is, those were the problems that I talked about. I didn't talk about how we address those. So I'll go into the details of each and every point that I talk about, and I'll say what Corda is and how it basically tries and solve those problems. All right, permissioned node. So Corda is a permission network. It's not like your generic traditional blockchain where you just download the node and get started, right? So in order for you to be part of a Corda network, you will have to go through a particular process of KYC, which will enable the operator of that network to take all the required information during your KYC. So you will be required to give out your legal name so that others would be able to identify whom they are actually transacting with. You can't just be an anonymous person on the blockchain, on the Corda blockchain. So that solves the problem of identity. Now you know, since you have been onboarded by a particular network operator who is operating the network on your behalf. Now generally this network operator is just an entity who is sort of an entry point to the network. He will make sure that whoever is getting onboarded in the network go through the proper KYC process so that the identity of the network is managed properly. Right, so first problem solved. We do not have anonymous people in the network. You have proper well-defined identities whom, when you transact, you know who they are. They have a legal name, and in case of issues, you can go to the court and take them to the court if any kind of conflict arises. Now, the second problem we talked about was, say, privacy, right? So you don't want to share all the information on the blockchain. Now, Corda is not, it doesn't do a global broadcast. It's not like the normal traditional blockchains where you do sort of this normal broadcast of messages or the gossip protocol, which we generally know of. We do communication on point-to-point basis. So Quadra makes sure that whenever you want to transact with any particular party or multiple parties, then those communication happen on a point-to-point basis. So for example, in this diagram, if you see, there are three parties. Basically, there is a notary pool, which we'll talk about later on. But say, for example, the Titan Technology partners want to communicate or do some transaction with Baytranscorp. Now, the transaction between these two parties is only known to both of them. Now, the vault that you see is nothing but the database of the node. So when this transaction is completed, this information about the particular asset that are transacting, a vehicle in this case, will only be known to the two parties involved. Now, third party, which is your Acme International, even though he is in the network, he will have no idea that there is an asset or there is a transaction which has happened involving that asset. It's completely unknown to him. Now, what we have done here is we have tried to make sure that the privacy is managed. Now, this particular asset is only known to people who need to know about it. Now, Quadra as a platform will make sure that whoever knows about a particular asset, they always see the exact same copy. Now, for this vehicle, these two entities, basically, your Titan Technology and Baytranscorp, will always see the exact same version of the vehicle that is in question here. All right, so that solves privacy. Now, finally, the problem of finality. Now, looking at this particular scenario where you have point-to-point communication, there is a very typical problem that might arise, the problem of double spending. So what double spending is, it's something through which you can basically spend the same asset to, or use the same asset at multiple different transactions. So basically, if you take an example here, if Titan Technology has already, for example, is selling this vehicle and he has already sold it to Baytranscorp, since Acme is not part of the transaction and Quadra doesn't allow him to know anything about that vehicle. So if Titan again tries to sell this vehicle to Acme, who is going to stop him? He doesn't know that that has already been sold, right? So what does he do? How does he know? So that's where the notary comes into the picture. Now, notary is a pool of nodes who gives a final say on a transaction. So every transaction goes through this notary pool, and the notary pool is responsible for making sure that there are no double spending attempts happening in the platform. So how does this work? It basically, now the question that you might have is, where is privacy here? Notary is seeing everything that's going on, right? So that's not really the case. The way notary works, it doesn't look at the content of the transaction. What it really does is it just looks at the structure of the transaction. So we have a UTXO model, if you guys know about, and it looks at different nodes of the UTXO model and tries to identify if that's a case of double spend or not. Now, in a very simple language, it just looks at the structure of the transaction to identify if a double spend attack is occurring or not. So it's still private. Notary just is a component which takes care of a certain feature or a certain aspect of the transaction, which is to timestamp the transaction, or as we say, notarize the transaction. Now, this also takes care of the fact that finality is not probabilistic in nature here. So basically, when you say a transaction has gone through the notary and the notary has given a go-ahead or notarized the transaction, that means that the transaction is final. There is no way you are going back, or there is no way you're reverting it. Reverting it in the sense, from a business perspective, you can always do a new transaction on top of a transaction to revert that, but that particular transaction, once has been done, cannot be reverted. Right. Now, the final piece is around ease of use. So the technologies that we use is Java, which is again used to build the platform. Actually, Kotlin, which is again a JVM-based language. But you could use Java or Kotlin to build any applications and deploy them on the Quadra network. Now, we use general RDBMSs to store the data, no magical tools there. And ActiveMQ, again, normal message queue and message broker to do message passing. So if you see all these technologies that I'm mentioning, these are real common languages that is used across the industry. Any enterprise software that you think of would be using these technologies. So it not just makes life easier for developers, it also makes it easier for companies to hire talent, right? So you would easily get people who have experience in Java or RDBMS or message queues. So there is no real requirement of going out and finding out people who have experience in some niche technology, right? So it's a win-win for both of us, for the developers as well as for basically the organizations who are hiring them. So finally, we have been able to solve most of the problems that we talked about: identity and finality. We have for identity, basically you have to go through the doorman or the network manager. For finality, obviously there's the notary pool, which will take care of that. For privacy, we have point-to-point communication. And for ease of use, we use well-defined languages or well-known languages which has been there in the industry and has been proven for years now. All right, so moving on, that's pretty much about why Coda was developed as a different or a particularly completely different platform rather than adopting something which is already there. So that's why we say Coda is a third generation language or third generation blockchain for that matter. And it's more or less a business blockchain which is more focused on businesses. We're applicable for most industries, but generally as a company, Vision, we are more focusing on fintech at this time, majorly trade finance, banking, and insurance. And we have a cross-industry ecosystem, which is called as the Coda network, where multiple different parties can collaborate together and make sure that they are having an easier day-to-day transactions on the Coda network. Okay, so that's about it. And moving on, we'll learn a little bit about how a Coda network is structured, or more or less the topology of the network, right? So as I said, there is an identity manager, which we, in our terms, called as doorman, and it manages the entry into the network, right? It has something called as a network map, which basically it updates from time to time. Now what this is it's more like a directory where you can go ahead and access who are part of the network. So for you to know who is the other party available, who are the other parties available in your network, you need to be able to see somewhere, right? So that's where the network map comes into the picture. It's the directory which allows you to see who all are available in the network and do transactions with them, basically. Now there are notaries and there are normal Coda nodes which will be run by different organizations. All right. How does a Coda workspace look like from a developer point of view, right? So you have the Coda network, which is different nodes, and then for each node will be connected to a firewall. This firewall will have two components, the bridge and the float, which will manage the incoming and outgoing messages. So this is an added layer of security, which allows you to make sure that you do not mess up with your own internal firewall. So Coda network, you just have to, whatever configuration that you have to do for Coda nodes to work, you would do on the Coda firewall rather than your main firewall. So that makes life easier. And then you have the RPC client, which is generally your gateway to the node as a node operator. So it's a client which will, it's nothing but a simple Spring Boot application which will expose certain APIs which you can fire through a end user application, which would more or less be a UI application. And through that APIs, you will in turn fire the node. So you're going to give any kind of commands to the node through this particular RPC client. So commands are more like starting a transaction, pulling out certain data, or anything that you want to do. So that all that functions can be taken care of by the Coda RPC client. Okay, so what is a Coda node, right? So when you say Coda node, it's for a general user, it's more like a black box. You don't have to know what's going on inside. All you do is you start a particular transaction. So generally in our term, we call it as flows. We'll try to understand what flows are later on. But for now, you can say that we are trying to start a transaction, and that goes to the node. And finally, when the transaction is completed, it updates the ledger. So there are different transactions that you could do, and finally, that will take care of updating your ledger. And all the low-level things like your messaging, your concurrency, your disaster recovery storage, or any kind of low-level things are taken care of by the node. You don't have to worry about how those things will be managed. As a node operator, all you have to do is go ahead, fire a command, and that will take care of the entire process of updating your transaction. So it will pull out all the keys and stuff required. It will do the messaging for you, and finally your transaction will be done, and the updates will be recorded on your ledgers. All right, so that's your node. Now coming to, that's about Quadra. So basically that's more about the platform itself. I will come into how you build applications on this platform. So applications on Quadra are called as Quad apps, or Quadra distributed, decentralized applications for that matter. So what are they? Well, they are, in Ethereum terms, you can think of them as smart contracts. Right? So these are the applications which are developed by developers and deployed on the Quadra node. So Quadra as such doesn't do much. You can sort of compare it with something like an Android or an iOS, which you can think of as the platform. Now the applications are more like your Facebooks, your Instagrams, which you install on the Quadra node. So without these, Quadra itself is of no use, right? So applications are which makes Quadra great. So each node will have multiple applications that you can deploy, and that's what you would basically use to communicate with different counterparties available on the network. So what are the different components that we have in a Quadra network is, or in a Quad app is, so basically for any bare minimum Quad app that you build, you would have three different components: the state, the contract, and the flow. So what a state is, if you try to understand it, it's more like your data model. So anything that you want to put on the Quadra ledger will be modeled as a state, right? So this is something which will get consumed, which will get updated and stored when you do transactions and stuff. Now these, there are certain sort of business rules for any transaction to be done. So these are written as contracts. So for any transaction to happen, these contracts must be fulfilled. These contract rules must be fulfilled. They're more like a business rules. Now, also, if you think of business transactions, there are business processes which needs to be taken care of, right? So that is taken care by the flow. It helps you execute those business logic. We'll get into details of each of these, just giving you a broader overview of what are the different components available. So let's deep dive into the Quadra state now. So state represents your on-ledger facts, which means anything that you want to put on the ledger is modeled as a state. So going back to the previous example of vehicle that we did, so this is something that you want to put on the ledger. So the vehicle, you can say it as vehicle state, and it would have multiple different properties like what's the make, what's the model, what's the variant, what's the fuel type, and a lot of other kind of things, right? So all these are different properties that could basically be written as a normal Java class, a simple POJO class. So all these properties will be represented as different fields in your Quadra or in your Quadra state class, and that's, so if you look at, we'll go into more details of how this class is built when we go into the coding part, but that's how things are done. It's pretty simple. You define what are your different fields that you want to have in your Quadra state, and just put them as a POJO class. So each node will see a subset of these states available on the ledger. Now this is where your privacy model of Quadra comes into the picture. So as I said, communications happens on a point-to-point basis, right? So states are distributed on a point-to-point basis. So only people who should know about a particular state are able to see that particular state. So for example, we have different parties. So bigger circles with names here are can be thought of as parties, and then the different numbers, smaller circles, can be thought of as your states or different assets you can think of. So if you look at this example, Bob and Alice only know about asset 1, while Bob and Carl know about 5 and 6, and similarly you can identify how different states are known to each other. So there is no global ledger as such. So you have each and every party only has a view of a subset of the global ledger you can think of. If you combine them all, well, it basically becomes a global ledger. And there's no single party who sees all of them, unless obviously your business requires you to do something of that sort. Then you model your application in that manner that he is able to do that. All right, coming to transactions. So states are stored on the ledger, as I said. Now with any normal blockchain, anything that you stored on the ledger becomes immutable. So does your state data. once you create a state, you put it on the ledger, the state becomes immutable. Now, how do you update this? You update this with the help of transactions. So what happens during a transaction is any transaction would have an input and it would have an output. Now, take an example here. If you see this particular state, which now belongs to Titan Tech, say the owner of the vehicle is Titan Tech, and he wants to transfer the vehicle to Acme International, for example. So what he would do is he would create a transaction, he'll use the state with him, he'll pull it out from his ledger and he'll put it as part of the input. And then he'll create a copy of that same state, he'll update the owner of the vehicle, and then he'll do the transaction. So once this transaction is completed, what would happen is this new output that is generated will be stored on the ledgers of these two counterparties now. Right, and the previous one will be marked as historic, which means this has already been used and you do not use it any subsequent transactions going forward. So anything that will be used is the most recent one that's available on the ledger. Right, so that's how transactions work. So this is where the UTXO model comes into the picture, right? Transactions output becomes input to subsequent transactions. So if you look at the examples here, well, basically the first transaction which has an output becomes an input of the next transaction. Now similarly, this middle transaction has output become the input of, again, the next two transactions that we are doing. So this is what the UTXO model looks like. So unspent transaction output, that's what the UTXO comes from. Now the different transactions that you could do, issue transaction which actually doesn't have an input, it only has an output, because there would be a time where basically you would have the very first transaction, right? You would be putting something on the ledger for the very first time, so no inputs because nothing to consume. This is the very first transaction. And then there are normal transactions, which is basically your move transaction or update transaction, whatever you might want to call them. Now these would have both inputs, both outputs. You are consuming something and you are creating new, so basically you're updating stuff on the ledger. And finally, there could also be transactions where there are inputs, but there are no outputs. This is the case of your burn transaction, right? Anything you want to put out of existence. Like, for example, say this vehicle goes out of existence in 20 years. You have to just put it, you have to just delete it for some way. So in Coda, how you do it is you use the most updated version, which is available on the ledger. Don't produce an output, which means the one that was there is consumed and there's nothing which is available. So you cannot use anything going forward, so it goes out of existence. Yeah, so that's states and transactions. Now coming to contracts. Contracts govern the evolution of state. What does that mean? Well, basically, any state cannot be updated just randomly. You will have to go through certain rules before updating them. So these rules are written as part of contract code. Right, so they are installed on each and every node, because obviously nobody trusts each other, so each and every node which are involved in a particular transaction will have to run that contract against the transaction to make sure that everything is going fine, right? And only if all the nodes available in that transaction are involved in the transaction, they give a go-ahead to the transaction, only then this particular update of the ledger happens. Otherwise, even if one of them says something is wrong, well, this transaction will be rejected and we'll have to take corrective actions based on that. Right, this is how your contract would generally look like. Yes?
And what about the privacy? All the nodes have to sign that contract.
So all the nodes involved in the transaction.
Involved in that transaction?
Yeah. Right. So there is also a catch to that. I'll come to that. So basically, this is how your contract would look like. Simple statements checking different kind of scenarios. So this is more or less vague currently to you, but we'll get to that when we go into the coding part. You'll understand more what's going on here. Now, transactions can be ambiguous, which means, for example, I'm doing a transaction, but what exactly is the aim of the transaction? So this is a vehicle which is part of this transaction, but what is it doing? Is it a registration of the vehicle? Is it a insurance? Is it something else, right? How do you know what's the intent of the transaction, right? And depending on that intent, you would have to make sure what is the different validations rules that you're running through, right? So unless you know what is the intent, you cannot validate the transaction with the correct set of rules. So that's where there's something called as commands which come to the picture. right? So commands are something which define the intent of your transaction, and based on these commands, you would basically run the correct set of rules to validate the transaction, right? There you go. So yeah, so instead of just verify, you could say verify uh, your registration or verify your service, and within those methods, you would write your different rules required to validate those transactions within your contract. Well, these commands also have signers attached to them. Now, to understand this scenario, say there is a case of a registration, right? You want to register your vehicle. So in this case, there are two parties involved: the owner of the vehicle and say the RTO or whoever is the registering authority. So in this case, it might be the case that only the registering authority is the one who should sign on the transaction, right? So it doesn't require a signature from the owner, because whatever the registering authority gives you, the number plate and all, whatever he says is the final say. You don't have a say on that, for example. Now let's take this an example, and you just accept whatever registration number you get from the authority. So you don't need to really sign on that transaction, because your signature is not really much of much importance in this particular case. But if you take the example of service, say for example you go to a service center and you want to service your vehicle, say you as an owner need to sign on the transaction to give a go ahead that, well, the service has been done properly, and also the service guy, whoever is doing the service, or the shop owner will basically give a signature saying that he has done the service properly. So this can be thought of as a scenario where you need signatures from both these parties. So there are different scenarios for different commands which would require different set of signers. And what that means is basically there could be multiple parties to the transaction, and it's not really necessary that each and every individual party available in that transaction are required to sign. The signers are only a subset of that particular parties available in the transaction. And depending from case to case, it would depend. It might be all of them, it might be just one of them, it might be maybe a few of them, right? So it depends on what's the intent of your transaction and who are really required to sign on that transaction. That's a business case which you have to decide while you build your application. So it's pretty simple. What are contracts? Just certain rules. So you'd have, say, rule 1, 2, 3, 4, and if all of them are said to be valid, only then your transaction is valid. And even if one of them fail, your transaction is invalid. Now, to understand how important this is, you can see that if, for example, the rule 3 is omitted out from this particular transaction, what the transaction is doing is transferring cash from Alice to Bob, right? And the amount, if you see, is 3, and the amount on the other side on the output is close to $1 million, right? So if rule 3 is omitted out, what you're doing is you're just transferring an amount of 3, and the other guy is receiving close to $1 million. So that's how important your commands are, your contracts are. So it makes sure that the sanity is maintained within your network, right? So yeah, that's how commands work. Now, coming to the final part, which is the flow. Now we have learned. Yes, there's a question.
With respect to contract, is the same thing as smart contracts, right? Or is it something different?
Yeah. So basically, for us, we will say that the entire application is your smart contract.
Okay. So I have been working on Ethereum-based, Solidity-based smart contracts.
Mm-hmm.
So I just wanted to compare and understand how different Corda or Cordapps work as a system when I compare with the Ethereum-based smart contracts.
So you build your smart contract, right, which becomes your application. So in your Ethereum. Now the smart contract is the combination of your state contract and flow here, right? Now, yeah, finally the flow part. Yeah.
Actually, I understand you're not a sales marketing person, but we use Ethereum, we use smart contract, we use R3 Corda and smart contract. So why would you pick R3 Corda over Ethereum? I mean, Ethereum's much more popular.
I initially mentioned what are the different sort of advantages of using it. What is the purpose of Corda, right? So it's built for businesses, things like privacy, your finality, and then ease of use, obviously, and your identity and stuff. So these are not provided by Ethereum. It's more of a public in nature. Now, if you have certain restrictions in all those areas, then well, basically you have to go with Corda. So that's where we differ from Ethereum in that manner.
No, but there are a lot more people on Ethereum. So would you be having interoperability between the two?
So there are work going on for interoperability. Yes, it is possible. It's not very seamless at this point, but yeah, it can be done. All right, so putting everything together will be our flow, the final part. So we have contracts and we have flows. So we now know how to model an asset, and we now know that how to write different rules to validate the transactions that we do on those assets. Now, how do we put them together? Now, let's take an example of a very simple trade, a two-party trade, doing a particular transaction of updating a particular asset, right? So different sort of, you would say, actions that they would take in a sequential manner, right? This is where your workflow comes into the picture. It could be much more complex depending on what are the different steps that you want to do. But for a very simple transaction, I think this would give you an idea of how things work. The first thing you do is propose a transaction. So at this point, it's just a proposal. It has not been finalized, so your ledger is intact. It has not been updated yet. So when I say propose your transaction, you create a transaction, you create your inputs and outputs, and verify the transaction, which is where you go ahead and run your part of the contract. So it's basically synonymous at different nodes, but still you have to go through and run this contract to make sure things are fine. So once you run this contract and everything is fine, the contract validation comes out to be valid, and then you put your signature to the transaction and pass it on to the counterparty. Now, depending on how many counterparties there are or how many signatories to the transaction there are, you send it out to that many number of participants. For our case, there is just one, for example. So it will go to the counterparty. Now, the counterparty at his end will also make sure that he runs the contract. He doesn't trust what is coming to him unless he runs his own contract and make sure that, yes, things are fine. So once he runs his contract, things are fine. He will also give his own signature and send it back to the initiator. Now at this point, you have a signed transaction, which is signed by you as well as your counterparty. Your transaction is complete. Your transaction is ready to be notarized. So this transaction now goes to the notary, and the notary will do the double spend check, timestamp it, and if the double spend check happens to be fine or there's no problem with double spend, so he'll timestamp it, he'll put his signature, and he'll send it back to the initiator, at which point he can then distribute this transaction to the related parties who are available in the network. Now, this might look like a lot happening, but from a developer point of view, you don't have to do any of this. This is just what happens in the backend. For you, just to call a particular method or a particular class, you have to call that, and the network will take care of all the things, like I said. So you just have to build your transaction, and you have to tell who are the different signers to it, and then call certain methods and all those things. The signing will happen, the sending it to the counterparty will happen, and then all the notarization and stuff will happen automatically. Even your when you're checking against the contract and stuff, all those things will happen in the background, and you don't have to worry about it. Finally, when this flow has ended, you will come out with a transaction and saying, with a transaction ID obviously, and saying that your transaction is successful or not successful. If it's successful, it would be updated. Right, so that's pretty much about how your Cord app really works. Next thing we are going to do is we're going to build a Cord app, and we'll see how easy it is to build a Cord app, and finally we'll also try to run it on a sort of local Corda network that will show you how to build that as well. Yeah, so I'll pass it on to Sneha to take it further from here.
Hi, can you hear me now? Yeah, just before I start coding, the question which we had from the audience, right? So there's a lot of work which is going on in the Ethereum and Corda integration space, okay? So we've been developing this bridge which actually connects Corda to Ethereum. And because of this now, what you will be able to do is you can now, let's say, move assets from Ethereum. You can, for example, you can move, let's say, ERC20 token from Ethereum, move these tokens, let's say, onto Corda, perform some processing, perform some trade, perform some, whatever logic you want to perform on Corda, again, with zero gas fees, because we really don't have the concept of gas fees in Corda because of the way it's architectured and all. There are a lot of details in that, but because of the way it's architectured, there aren't any gas fees. So you can do your trade, you can do the processing in Corda, and then the bridge also provides you a way to redeem these tokens back onto the Ethereum network. Yeah, having said so, let's get started off and let's do some coding together. So the next 1 hour, what we're going to do is, Ashutosh has explained you all the concepts within Corda. So for the next 1 hour, we'll be developing a simple Corda app. So I'll be doing a live coding over here, and I'll show you how easy it is to develop a Corda app. For developers who have their laptops, feel free to code with me, because it's going to be easy for you to code with me. So if anyone is, if they have your laptops, please feel free to open your laptops. You just really require Java and IntelliJ IDEA and Git. That's it. So if you have that, please open it and you can actually code with me. If you do not have your laptops, we'll also share you the recording of this link. So that is also fine. So for today's session, what we are going to do is we are going to code this Bootcamp Corda app. The link for it, as you can see, it's on GitHub. You can go to Corda's repo and you'll find the Bootcamp-Corda app project or Corda app available on the GitHub repo. Just go over here, clone the repo, and let's get started. So I've already cloned the repo over here. Now what we are going to do for today's session is, this is the Bootcamp Corda app. I've cloned so basically I've cloned this Corda app on my system. Now before even I start off with this Corda app, one important thing is, please feel free to join in the Corda Ledger Slack channel. So all of the developer audience, or you'll find our entire developer relations team on the Corda Ledger Slack channel. You'll also find the engineering team on the Corda Ledger Slack channel. So please feel free to join in the Corda Ledger Slack channel. And if you have any questions for today's bootcamp or any technical questions going forward, feel free to put in your questions over there as well. Now let's get started. Now, what do we plan to do for this bootcamp, right? What I'm going to do is, let's assume this scenario. Let's assume that there is a bank, okay? Let's call it the issuer. Let's assume that there is one particular bank, and then let's assume that there are several parties, or there are several, let's say, several entities, okay? Now, what we want to do is, the bank wants to, let's say, issue, let's say, a note worth ₹10 to, let's say, entity ABC, okay? So what's the scenario? The scenario is there's a bank, and this bank is the issuer, and this bank wants to issue a note of some worth of some, let's say, 10 rupees, 100 rupees, 1,000 rupees to a particular entity. Now, what we want to do is we want to represent this particular scenario on the Corda blockchain. We want to make sure that what you see is what I see. We want to make sure that the bank and this particular entity, they both are aligned and they both know what has actually been issued, right? They both are in sync. We want to make sure that this is the scenario. So let's start off. So again, to represent this scenario on the Corda blockchain, what we are going to have is, we are going to have multiple parties, one party being the bank, and one party being the entity who the bank will issue a note worth of some amount, okay? Now, Ashutosh already explained, to build any Corda app, you just require 3 things. You require the state, contract, and the flow. Now, if you look at the state, again, just a quick recap on what we discussed. Now, all the attributes or all the properties which, let's say, the bank and the owner of this particular note, right, all the attributes which both the parties want to make sure that what you see is what I see, right? All the attributes which the entities want to make sure that what you see is what I see will go as a part of state. Okay? So let's say in our scenario, let's say that the bank and the ABC entity, let's say both of them want to make sure that at any point of time, who actually the issuer was of this particular note, who actually the current owner is of this particular note, and how much amount was actually issued. Ideally, this would be something which all the entities would want to make sure that what you see is what I see, right? So all these attributes which you want to make sure what you see is what I see will go as a part of the state in Corda. Now, that's why to represent a state in Corda, we are going to use the token state class. And I'll show you how you can actually code and write a state in Corda. So that was it about from a state perspective. Now, this is usually a typical transaction in Corda. So Ashutosh already mentioned that this is how usually a typical transaction looks like. It will usually have some inputs, some outputs. For our particular scenario, it's an issuance transaction. That is, the bank is going to issue a note to some entity. And that's why, since it's an issuance transaction, it's going to issue the note for the very first time. And that's why we are assuming that it will not have any inputs. Okay, so it's not referencing any state from the ledger, from the blockchain. As of now, since it's an issuance transaction, we'll assume that it doesn't have any inputs. And we are saying that this is an issue command. Okay, and we are saying that this issuer will be issuing this particular state. Now, this particular state, again, as I mentioned, is going to have these kind of attributes, right? Now, Ashutosh already also mentioned that you also can specify the intent of the transaction by specifying the command. So for our particular scenario, the command is what? The command is an issue command. So the bank would really want, what it wants to do, it wants to issue, let's say, a token, a note. And that's why the command is issue command. So really, this is the kind of transaction which we are going to build, right? Now, how do we build this transaction? How do we actually execute this particular transaction? And that's where the flow comes into picture. So again, the flow again, just to revise what Ashutosh said, flow is what at the end of the day, it's a series of steps which we want to perform in order to achieve something, in order to perform this issuance of transaction, in order to perform this issuance of the note. So what we are going to do, we are going to follow a series of steps which will actually build this particular transaction. And this particular transaction will have this particular layout. It won't have any input. It will have one output. It will have an issue command. And this really is just a proposal at this point of time, right? At this point of time, the issuer is just creating this transaction. And at this point of time, it is still just a proposal. The transaction is not committed to the ledger yet. The transaction is not finalized yet. It's just a proposal. Now, once the issuer actually creates the proposal, it will pass this transaction to a contract. So we have seen that we saw something that we have something called as contract in Corda, right? So within this contract, we will add a lot of rules. So to actually, to actually convert this proposal into an actual transaction, basically the issuer will actually send this proposal to this particular contract. And we'll be writing certain rules in the contract. And if all of the rules are satisfied by this particular transaction, the issuer will actually sign this transaction, sign this proposal, and then the issuer will send this signed transaction to the counterparty, which is, let's say, the owner, which will be the owner of the current note. And then the owner will also do the same thing. The owner will also take this particular proposal, this particular transaction, send it to the contract. The transaction will be again run against all the set of rules. And if everything is good, the owner will also sign the transaction, send it back to the issuer. The issuer will send this particular transaction, which is signed by both the parties. And this transaction will be sent to the notary for checking for double spend. If there is no double spend, the transaction will be finalized and the transaction will be recorded on both the parties' database, right? So at any point of time, basically, if you build a transaction, you usually pass it to this particular contract, and the contract is run against this particular transaction, and that's how you can actually do a state update. You can actually, that's how you can say the blockchain evolves, or that's how the states get added to the blockchain. That's how the states get added to the database, and that's how a ledger evolves, right? So these are the series of steps which are required to actually evolve the ledger, to actually evolve the blockchain. Now, what kind of rules we can add in the contract? As I said, this is an issuance transaction. So probably we could add, let's say, we could say that I want to make sure that this particular transaction doesn't have any inputs. I could also add, let's say, I could say that I want to make sure that it has this particular contract or this particular transaction has one state, which is the output state, right? And I could probably also check the amount, because I want to make sure that the bank issues me a note whose amount, let's say, is positive. It's not negative, right? I could also check the signers in this particular contract. Who are the required signers? And all of these rules we are going to add now in the contract, right? So I think if we are clear with all of this, we'll move forward and let's code together. So we are going to code three things. We are going to code the state, which basically consists of all the properties which you want to make sure what you see is what I see. All these properties will go as part of the state. The contract will consist of all the rules which let's say so whenever we build the transaction, which is the transaction will be built in a flow, that we will pass this particular transaction to the contract. We will write all the rules within this contract. This transaction will be, or basically the state change will be governed by this particular contract rules. And if everything is successful, if there is no exception thrown by the contract, then the issuer will sign the transaction, send it to the owner. Owner will do the same thing. Owner will run the contract. If he's also happy, he will also sign the transaction, and the transaction is notarized, and then the transaction gets recorded on both the parties' database. Now, let's start off and let's start with, so if you look at the project, this code app, you can see there are two folders. So this is a contract folder and there's the workflow folder. So within the workflow, we have the tokens issuance flow. This is where we'll actually write our flow. This is the contract where we have the state class and the contract class. So we'll write a state in the token state class. Now, for Corda to understand that this particular class is a state class, you have to implement your class with the contract state interface. Now, this contract state interface, let me just comment this particular annotation at this point of time. So this contract state interface, this has one method. Let's implement that method. The method which is we have implemented is the get participants method. Now, if you go into the contract state, you would see that it consists of a field which is the participant. Now, at any point of time, right, what we are doing is we are creating this particular state. Now, at any point of time, let's say, at any point of time, let's say this state changes. Let's say this state gets created on the ledger, or let's say that this state gets updated on the ledger, right? At any point of time, whenever there are some state changes, all the parties which you want to make sure that should get notified of these state changes will go as a part of the participant fields. So now let's start. Let's start adding what we had discussed. Let's add the required fields to our state. So what we had discussed, we want to, let's say, add the issuer. So let's say that we want to add the issuer to the token state. Let's say that we also want to add who's the current owner of this particular note. And we also discussed that, let's say, we are also we might also be interested to know what the exact amount is, right? So these are the properties which I've added to token state. And as I mentioned that at any point of time, whenever this particular state changes, let's say that I say that I want the issuer and the owner to be notified of the state changes. And that's why the issuer and owner will go as a part of the participant list from the contract state interface. That's it. Now, what we are going to do today is we are going to follow a test-driven approach. So there are certain test cases which you can see in this particular Coda app. I'm going to uncomment each and every test case, and I'm going to accordingly change my code, and I want to make sure that all the test cases pass. So let me uncomment the first test case. It says that the token state has to have a constructor with all these fields. So let me do that. I'm going to do a control N in IntelliJ IDEA, select the constructor, select all the fields, and I hit enter. So let's see what the other test cases are saying. This says that the token state should have getters for all the fields. So again, I'm going to do a control N, select getter, select all the fields, and hit enter. Now we have the getters for all the fields. Now next, what we want to do is we want to make sure that the token state implements contract state interface, and I think we've already done that. The next test case says that that we want to have issuer and owner as the participants field, and I think we've already spoken about it, why you require this to add in the participant field, and the issuer and owner has been added to the participant field. So I think that's really it. So let me run the test case and see if everything looks good. So now I'm running the test case, and all the test cases are successful. So I think we are good with the token state. Again, quick revision, what we did for Coda to understand that this particular class is a state class, you have to implement it with the contract state interface. Contract state interface has just one method, which is the participant list. So all the parties which you want to make sure are notified of any state changes should go over here. We've added the relevant fields over here. So all the fields which you want to make sure what you see is what I see will go as part of the state. We added the constructor, and then we added the getters. That's really it from a state perspective. Let's move on and look at the contract now. So this is the contract class. Again, for Coda to understand that this is the contract, you have to implement it with the contract interface. This contract interface has one method, which is the verify method. So when we actually build our transaction in the flow, we are going to call this particular method. And while we call this particular method, we are going to pass our transaction to this particular method in this particular input. Okay? So let's assume that we will, so when we go to the flow, what we are going to do is we are going to create a transaction. This particular transaction will have an issuance transaction. It will not have any inputs. It will have one output, and it will have the required signers, right? So all of this, we want to verify that whether we have actually created a correct transaction. So all of this we are going to check over here now. So again, quickly, what we have discussed, we are going to add all these rules in the contract. We are going to make sure that the transaction doesn't have any inputs. It has one output. The output is of type token state. We want to make sure that the amount is greater than 0. And we also want to check whether there are required signers for this particular transaction, right? So we are going to test and write all of these rules now in the contract. Now again, for this, we are going to follow a test-driven approach. And what we are going to do is we are going to uncomment each and every test case and accordingly make changes in the contract class. So this says that token contract implements contract. I've already done that. So let's move on and let's try to run the next test case. So what this test case says, this says that the token contract requires 0 inputs in the transaction. Okay. Now let me run this test case. Now what this test case is doing is, this test case is actually, when I run this test case, it failed. And it says that, so what is this test case doing? It is passing in an input to this particular contract, right? But what we had decided that for our transaction, we won't have any input. And if by mistake, someone passes an input to the transaction, ideally, the contract should catch this exception, and ideally, the contract should throw an exception. That's what we had discussed, right? but this contract is not implemented correctly, and this contract is not throwing an exception when you are actually supposed to throw an exception when, let's say, someone passes an input to this particular transaction, right? And that's why this test case is failing. Now we are going to correct that, and now what we are going to do is we are going to actually throw an exception if someone sends us a transaction. Let's say that if someone sends us a transaction, and let's say that the get input states, if its size, let's say it's greater than, let's say if it's not equal to 0, we should ideally throw an exception. So I'm going to say throw an illegal argument exception. Input state size has to be 0, right? So let me run the test case again. And now let's see if the test case passes. Yes, now the test case passes, because if we give such an input, if we give such a transaction which has one input, now the contract will actually throw an exception, right? So this particular test case says that if an input is given, the transaction should fail, and the transaction is actually failing. And that's why this test case passes. So similarly, there are all these test cases written, and let's move on to the next test case, which says that the transaction actually should have only one output, and if you pass two outputs, the contract will fail. So let's do that. Let's say that if the transaction dot get outputs, if the size is not equal to, let's say, 1, I'm going to throw an exception saying the output size, let's say, has to be always 1, right? So now let's run this test case and see if we've correctly written our rule. Yes, it passes. Let's move on to the next test case. This says that the token contract, it requires one command, which is the issuance command to the transaction. So let's check that. We want to make sure that the transaction dot get commands dot size, if it is not equal to 1, again we throw an exception saying that the command size always has to be 1. I'm going to run this and see if we've correctly written. The next test case says that the contract requires the output state should be of type token state, right? So what we want to do, we want to issue a token state. So let's check that. So we want to check that if transaction dot get outputs, let's say get of 0, transaction dot get output of 0, let's say that, so this is a contract state, and what I want to do is I want to check that if the contract state, if it's an instance of token state, then we are fine. If it is not, so if it is not an instance of token state, then let's throw an exception saying that the output has to be, let's say, a token state. So let's run this test case and see if we have correctly written. Yes. So we are good over here as well. Now what we want to make sure, we want to make sure that this token state which we have issued has amount which is positive. So we'll check that. So we'll say that if this particular contract state dot get amount, right? If it is less than, let's say, 1, then we throw an exception saying that the amount is, let's say, negative. Let's run this as well. Now the next test case says that yes, this is successful. This test case, now this says that what we want to check, we want to make sure that the command which we have is of type issue command. So So we want to check that if transaction dot get commands dot get of 0 dot this get value is instance of, let's say, an issue command. So if it is not an issue command, we should ideally throw an exception, right? So we'll say that not an issue command, or basically we can say that this has to be an issue command. So let's run this and see. So yeah, this is also successful. And now the last one, which is what we want to make sure. We want to make sure that both the issuer and the owner are signers for this particular transaction. So we'll say that if transaction.get commands dot get of 0 dot get signers, and let's say that if this contains so if let's say this contains the issuer's key, then we are good. If this doesn't contain the issuer's owning key, then we are going to throw an exception saying that both should sign. So let's run this and verify as well. So this is also successful. So I think we've run all our contract states and we've completed a contract, and these are the kind of set of rules which you can add in your contract class. Now again, one thing which we've missed to do is we have to uncomment this particular annotation. So this ties this particular token state with this particular contract which we wrote as of now. So at any point of time, whenever the ledger is updated, whenever this particular state is changed, created, evolved, updated, this will be run against this particular contract, right? So we are done with the state contract, and let's move on to the flow. Now in the flow, what we are going to do is this particular flow, again, as I mentioned, this is a series of steps, and we want to issue, let's say, a note from the bank to this particular entity. To do that, the bank or the issuer is going to run this particular flow from its terminal, from its node, right? So when we run this particular flow from the issuer side, we will put in who the owner should be of this particular note and what the amount should be for this particular note. Okay, we'll take that from the user. We'll take that from the bank himself. Now this is a typical flow which you can write. Again, to create a flow in Corda, you have to extend your class from the flow logic class. At any point of time, you require the notary to check for double spends. There are APIs available to readily get notary. So as a very first step, use Service Hub to get a reference to the notary. To get the issuer, basically the issuer in our case is going to be the person who actually runs this flow. The bank is going to run this flow. So get our identity will return the issuer. Now what we are going to do is we are going to create a new state of type token state, right? And then we are going to propose a transaction. We are going to create a transaction. And once we create the transaction, we are going to pass this transaction to the contract. And then this particular transaction will be run against the contract, the set of rules which we just wrote. And if an exception is not thrown, we'll move ahead and the issuer will sign the transaction. Once he signs the transaction, the issuer will simply send the signed transaction to the counterparty. The counterparty will also perform the same things. Internally, the counterparty also does the same thing. He will also verify the same transaction will be run against the contract. He will also sign if everything is good. And then finally, the issuer will call the finality flow to actually record the transaction on the database of both the issuer and the owner. So these are the kind of flows, inbuilt flows, which you can readily use in your Corda app. And yeah, so let's do that. Let's create the new, let's say, token state. The issuer we've got it from get our identity. The owner and amount is something which we will pass in from the command line. So this is our token state. Let's create the proposal. Let's create the transaction. Let's specify what notary we want to use. For transaction, as this is an issuance transaction, there won't be any input state. Let's add the output state, which is going to be the token state. Let's also add the command, which is going to be the issue command, and let's specify who the signers will be. Signers will be the issuer and the owner. That's really it. So this is the proposal. Let's pass this proposal to the contract, and then the contract will run all these rules which we just wrote. And if everything is successful, the flow should run successfully. So let's do one thing. Let's again run all the test cases. I'm going to uncomment all the test cases, and let me run these test cases and see if the flow is successful. Here again, if you see, these are the things which we've written. This checks if the correct notary is used. This checks if it has only one output state with the correct amount. This also checks if we are running it against the contract. This checks if we have an issue command, and also this checks whether we have the required signers. So the flow is running. Once the flow is successful, we are going to deploy a local Corda network on our system, and we are going to deploy this Corda app on all the nodes within our system, and then I'm going to fire. So the flow is successful. So I think we are good to go. So let me show you how you can actually deploy this Corda app on your local system. So go to the command prompt and go to the path of your Corda app and just fire the deploy nodes command. So this deploy node command, what internally it does is, it actually deploys a local Corda network on your system. So if you see over here that these are the directories which are getting created. We have party A, party B, party C, and the notary. So these are the participants of our Corda network. For this particular Corda network, we have one party, one notary for this particular Corda network, and these are the parties which are part of the Corda network. So once all of this is created, the network is deployed, we are going to issue, let's say party A is the bank. So we'll see how we can issue a token state from, let's say, party A to party B. So let's wait for the local Corda network to be deployed. Yes, so the build is successful. So if you actually go and look at your build/nodes directory, you will see that this is the local Corda network which is deployed. You have notary which is deployed, party A is deployed, party B is deployed, party C is deployed. The Corda.jar, which is the Corda platform, is deployed on each node. And this is a Corda app, which is the contracts jar and the workflows jar. This is also deployed on each and every node. So let's start off all the nodes. To do that, go into this particular directory, which is the build/nodes directory, and just do a ./run nodes. So this will start off all the nodes on your system. So let's give it some seconds for the nodes to start off. Yes. So party B has started, party C has started, Notary has started. Let's start off party A as well. Yeah, so party A has also started, right? So let's do one thing. Let's do a flow list. And here you can see that this is our tokens issue flow. So let's start off that particular flow. Let's assume that party A is the bank. And let's say, issue a note to, let's say, party B. And let's say that I want to issue a note worth, let's say, 1,000 rupees. Party B is started, notary is also started. So when I hit enter, the flow is getting executed, if you see. And then the flow is completely successful. So if I hit on run, and now we'll actually go into the database of all the parties and see if we have our token state recorded on both the parties' database. So if you hit on vault query, you can specify the So if you do a run, let's say when you do a vault query, specify the contract state type. So what we are going to say that I'm interested in this token state. So copy the path to the token state and just hit enter. So as you can see, this is the token state which was created on the bank node on the party A node. The issuer was party A, the owner is party B. An amount of 1,000 has been issued from party A to party B, and this was the contract which was used. So let's again fire the same command on party B side as well. Now if you see, the same state is being created on the party B side as well. Now if you fire the same command on party C side, you should see that though party C is within the same network, though party C is a part of the same CODA network, party C is not even aware that such a transaction took place between party A and party B. Yes. So I think that's about it from a demo perspective, from a CODA perspective for today's session. Yeah, so again, as we wrap up, few things. Please do join in CODA Leisure channel. If you have any questions, feel free to ping us over there. And secondly, we are hiring a lot. So we want good developers. And so please visit r3.com/careers or get in touch with me, Ashutosh. There are a lot of openings over here in India. So yeah, please look out for the openings. Reach out to us for any questions as well. Yeah, thank you. Thank you so much. Thanks a lot.